The center of mass of a solid hemisphere of radius 8 centimeter is x from the center of the flat surface, and the value of x is. See, we know that the center of mass of a solid hemisphere. Now, when I say center of mass of a solid hemisphere equal to x bar, y bar, we should understand that center of mass of a solid hemisphere, when it is lying, when the flat, when this portion, right, when this flat bottom, it is on the xz plane, and the height varies along the y-axis, then we have the center of mass of solid hemisphere as x bar y bar equal to 0 comma 3r by 8, which means the value of x bar will be equal to 0 and the value of y bar is 3r by 8. See, that is where the question in itself becomes really beautiful, because it has not specified any any of the axis wherein the body is placed. So the center of mass of solid hemisphere of radius is x centimeter. So we know that the radius is given as 8 centimeters. So we have 3 by 8 into r, which gives 3 by 8 into 8, and therefore the y bar is equal to 3, and the value of x here will now see, there might be a little doubt that comes into your mind that it is given as x centimeters. So is this x centimeters denoting that the center of mass is lying along the x-axis? Well, that could be the case. That also could be the case. So what we need to understand here is, if the figure is lying symmetric with respect to y-axis, I'm sorry, if the figure is lying such that the bottom of the hemisphere is lying on the xz plane and the height is along the y-axis, then the coordinate of the center of mass will be x bar comma y bar with x bar equal to 0. Okay. If this is lying the other way around, with the bottom of the surface lying in zy plane and the height lying along the x-axis, then the y bar will be equal to 0 and we have x bar is equal to 3r by 8. Okay, so yes, see, so to write this is to come into the solution and to get the answer is one part, of course. So the value of x here will definitely be equal to 3. But as we said, if this is along, if the question means along the x-axis, then definitely the orientation of this figure here is not like this. It would be the other way around. It would be something, it would be like this. So the figure will be lying along like this, if it means along positive x-axis. But anyway, the answer, the final answer wouldn't vary. It would still be 3 by 8 into r. Okay, now which essentially means that center of mass of a hemisphere is dependent on the radius of it, and it is very close. 3 by 8 r means it will be very close to the bottom edge of the bottom surface of the hemisphere. Okay, now how did we arrive at this formula? How did we arrive at this values, x bar comma y bar is equal to 0 comma 3r by 8? I know that some of us may feel a bit confused about this portion, these two diagrams. What I'll do is I will make sure that both of these coordinates of center of mass are derived properly, and we'll distinguish the corresponding values. Things will become really clear to you. Okay, having said that, the y bar is 3 by 8 into r according to this figure. Let us first derive the center of mass of a solid hemisphere lying in the xz plane with the height along y-axis.